This is Lantec's Video Interface Edition 16, in which I'll be bringing you all the news from the industry, including the just announced pricing for Windows 95.
I'll be investigating the new Super Server from IBM and researching the subject of video conferencing.
I'm going to be showing you a software package that you're going to want as soon as you see it. I shall also be talking with Intel on a technical level about the P6 and speaking with one of the founder members of the Media Lab at MIT. So stand by the pause button. Here's the stop frame index to get an accurate fix on the start points. Zero your VCR time counter now. One news item that Alison hasn't got this month is that just a few days after the last edition of Lantec's video interface was recorded, we announced the purchase of Rapid Recall, a name well known and much respected in the IT industry for 9 years. Rapid Recall are, like Lantec, BSEN ISO 9002 registered. Jim Rusu, Lantec's chairman and chief executive, said, Rapid Recall's quality procedures, product ranges and customer profile were so similar to Lantec's that it was a natural fit. We are pleased to welcome Rapid Recall's staff to Lantec and of course their customers. A spin-off of the buyout is that Video Interface's audience has suddenly increased dramatically, so if you're watching us for the first time, welcome and let us know what you think of the programme. You'll find a reply paid card in the box and, as our regular viewers know, we love to hear from you. Right, if you read PC Magazine, that's one of Guy Cuny's, you may remember, you may have seen this review of a software product by the name of Visio. The review sounded almost too good to be true, as it gave it a usability seal of approval, in fact the only one allocated to software in this category. So we've invited along the software products manager of Visio International to show us the product. Welcome, Rick Temminck.
Thank you.
Rick, for those people that haven't seen the review and haven't seen the product, tell us first of all what it does.
Well, Visio covers a whole range of standard business diagramming types, from the standard flow charts through to org charts, project timelines, office floor space layouts, and even network schematics and more technical type of drawings.
Right. But there are other software products that already do all these things, aren't there? What makes Visio different from all these others?
Well, Visio is fundamentally different for a number of reasons. First of all, the typical business user has a requirement for a whole range of diagrams, not just flow charts or org charts. So there's a real advantage in using a product like Visio, which has a very, very wide scope. Okay. Secondly, the diagrams you create in a business environment are usually an occasional application. You don't spend all your life doing them, but when you do them, you usually use them in a suite environment, so you use them within other applications. So the Visio answer to that is to really integrate well within that environment and make the product highly usable, and that was confirmed by PC Magazine, for instance. The last major difference is that it's a known fact that business people can't draw. So this can be a real barrier to doing diagramming, and Visio has a solution to that called Smart Shapes. The Smart Shape is an intelligent drawing object that really helps you as a user to create that drawing. So the concept is you do the thinking, we'll do the diagramming, and that works really well.
Mm-hmm. Some of the ways that Visio does things are actually quite different, I noticed, from a typical drawing package. Perhaps you'd like to show us the way that this works. I think we all want to see it.
Yeah, I'll show you an example using a flowchart as the drawing type. Mm-hmm. Let me just start Visio through this icon. That starts Visio with the flowcharting stencil.
Right.
What you can see here is a standard menu bar, all standard windows, and we also have a toolbar. By right-clicking on that toolbar, I can actually set Visio up to look like Microsoft Office or Lotus Smart Suite, which can be very handy for people that are already familiar with that.
So the integration with your Office desktop suite is customizable just that easily?
Yeah, that's very easy to do.
Right.
In the main body of the screen, we have two windows. The green one over there is what we call a stencil. Mm-hmm. The stencil contains the Smart Shapes. And over on the right-hand side, we have a drawing page. Now, all I need to do in Visio to create a diagram is simply pick up a Smart Shape and drop it onto that drawing page, as I'm doing here. So it's extremely simple. We have a very useful icon on the toolbar here called the connector tool. Mm-hmm. Once that's switched on, Smart Shapes will connect automatically, so I don't have to create those connections.
Right.
Visio does that for me.
Right.
Okay, let me just drop one more shape on here and then show you what the smartness of the shapes really means.
Okay.
We can see that these shapes are connected, but they're actually intelligent connectors. So if I move a connected shape over here, you can see that the line follows and even switches connection point. Right. Another example of how smart the shapes are is adding text. In a more traditional drawing package, you'd have to pick up a text tool, type text, and then center the text object on top of the shape, which is not really the way people think. In Visio, all I need to do is type a descriptor in there, and you can see a couple of things happening. First of all, I didn't have to pick up a text tool, it just happened.
Right. Yes.
Also, Visio zooms in, allowing me to read what I'm typing, which is very useful.
True.
And I even get a textual toolbar up here that allows me to quickly maybe reduce the point size a little bit and make that text italic. So it's all very, very simple, very easy to do.
Right.
Okay, so now we've created a very simple flowchart, and we'd like to include that in a document. And that's, again, where the suite integration, the integration with other Windows applications comes in. Let me just tile a copy of Visio with a Microsoft Word for Windows document, and show you how easy it is to actually get this drawing over into my report. All I need to do in Visio is select that diagram, pick it up, and drag and drop it over into the file. So there's no file conversions, no import, export, it all just happens naturally. Right. And that's really how people want to work.
I could use that.
Once the drawing is, or the diagram is in Word for Windows, I can even edit it by double-clicking the Visio drawing. We go into something called in-place editing mode.
Right.
And you can notice we're still in Microsoft Word, but I can now edit the diagram simply by right-clicking on the object and, for instance, changing a fill to red.
Right. So full OLE support.
Yeah, the best OLE
support
support you can imagine.
Right. Okay. Our users, I should imagine, or our audience who might be users of this, would be very used to doing things like network diagrams. I would imagine they're pretty much a staple of their diet. Show us a little bit of that, could you?
Okay. Well, the great thing about Visio is that whatever drawing type you do, the way it works is very consistent. So I've just loaded a drawing that I created earlier. It's nearly completed, but if you look at the screen and look over to the stencil on the left here, you'll see that it's very similar to the flowcharting stencil.
Yes.
The only difference really is that we're not showing boxes and lines anymore, but we're showing computer equipment and network structures. But the way it works is exactly the same. If I just zoom in to this area of the screen here, you can see that I could easily drop in a network structure here, maybe resize that a little bit, and then drag out one of these connectors to connect up to this PC at the top. The other one here.
Are these smart connectors as well? If
Yeah.
you move something, do they stay glued and attached?
Yeah, they do. If
Right.
I move the structure down here, you can see that the line's rubber band again.
Must
And it's
say
exactly the same feature that we're using
It
in
would save
flowcharting
me
before.
redrawing lines time and time again when I discover I haven't left myself enough space and I have to move things over and so on.
It's not easy, not just easy to create things, it's also very easy to edit things.
Indeed.
And we can even go further and add data to the drawing. For instance, if I just double click this shape here, it will pull up the little database record behind that shape, and it'll show me data particular to that particular drawing.
Very clever. So what comes in the Visio box? What do you actually get when you buy the product?
Okay, Visio, the standard product comes with 22 stencils and a total of 750 shapes. And that covers all sorts of drawing types, from flow charting, org charting, timelines, through to electrical engineering and space planning.
Right, okay. Space planning meaning office floor plans and
that's correct.
Things like that.
Yeah.
Okay. But you have a series of other smart shapes and so forth that you can actually buy in addition to this, don't you, I know?
Yeah, that's right. We have a total of 15 additional smart shape libraries, and they cover areas from advanced flow charting, advanced network diagramming, through to technical applications such as chemistry, chemical engineering, mechanical engineering. We even have a range of home-related ones such as landscape planning and home planning.
All right. Rick, it's a fascinating product, and I did say that everybody would want it as soon as they saw it. Certainly I would like that on my desk. It's fairly inexpensive too.
Yeah, it's only £99 plus VAT.
Right.
So it's very affordable, and the smart shape libraries are £39 plus VAT, so it's actually very, very affordable.
Well, we let you get your plug in there, which is something we don't often do on this programme, but nevertheless, it's a fascinating product. If you would like a reprint of the PC Magazine review, covering all of the products in this category, not only Visio, but you can see how Visio comes out. Or indeed you would like a working model, a trial size diskette, if you like, of Visio, so that you can play with it yourself and see whether you think it would be appropriate to you. Drop us back the reply pay card. Just write your name, your company name, and in the product section up at the top, just write Visio, drop it in the post, and we'll make sure you get one.
Brian, while I've got you on the line, maybe you can help me with this presentation I'm trying to put together at the moment. I've got a graph here on the performance of Pentium processor, and it's got the latest 120 megahertz part coming in at a really low value. You prepared the data. I don't know where it is. Can you help me with it?
Yeah, sure. I think I can see what the problem is here, Steve. So let me just go back to the root of the problem, and I'll click on this, which will actually launch the Excel spreadsheet from where this came originally. I think the problem is if I just, now that we're in the Excel spreadsheet, let me just go to the original table where this came from, and you can see fairly clearly that I've made a mistake there. That should be 1,000 icomps rather than 100 icomps. So if I just change that and then take us back to the original graph again, you can see that it's actually much more in line with what it should be.
Steve, let me interrupt there, if I may, and introduce you. With me is Steve Cate, who's the Analyst Programs Manager from Intel, and at the other end is Brian Welsh, who's the Product Manager for Intel's ProShare. Steve, we've been looking at your video conferencing. Would you just like to highlight what you were doing there? You seem to be actually sharing data.
Absolutely. This is more than just simply video conferencing. Of course, we have that as well, as you can see. We have two systems here which are connected over ISDN. Both systems are ProShare video systems, and what we're able to do is, as well as see and hear each other, we're able to work together on real work, on real applications. So I've got ProShare and PowerPoint running on this machine here. I was able to share my PowerPoint presentation with Brian, and in real time he was able to make some changes to that presentation by clicking on objects and loading some of the data behind them, stuff that I didn't know how to do. Brian prepared this data. He doesn't have PowerPoint or this information on his computer in Swindon. I have it all here, and yet he has full control of that machine.
That's a remarkable advance since last we saw ProShare. Are there other features that you would like to highlight to us, perhaps about the image that we're receiving here?
Well, the image I have shrunk down at that particular size because it's convenient while we're working on data. But of course, if I wanted to make the image larger of Brian, I could quite easily do that. And that becomes particularly useful if you're wanting to look at some video coming in from the other end. If Brian wanted to show me a model, for example. In fact, I think, Brian, there's a videotape which I haven't seen yet, which you wanted to review with me. Is that right?
That's right. It's the tape that we looked at the other day. So what I'd like to do now is actually just run that tape and see what you think of it before we go to the final editing, Steve. So let's do that now.
Brilliant. Thanks, Brian. So what Brian's doing now is that the tape machine is also connected up with the computer as well as the video camera that's showing Brian. And he's going to put the video feed into the computer from the VCR rather than from his camera. So what we can see here now is a video sequence. It's actually one of the Intel ads that's running off the VCR player that he's got. We're not pumping the audio through as well, so we can still hear Brian and Brian can hear us, right?
Yes, that's right. We haven't put the audio through in this case, but you can see the visual, which should help give you a good idea of the advert.
So you can imagine the power of this sort of capability, say for an advertising agency or anybody who had video they wanted to work with and review at a great distance.
I think we can usefully say then that this is an emerging technology that's arrived, but usually when we're dealing with these technologies, there's a problem with standards. And I seem to remember reading in the Financial Times that indeed the standard H320 was one that Intel resisted for a while. Can you explain that?
H320 is a very important standard. It's not something that Intel has been able to do in the past, primarily because of processing power. Let me try and explain a little bit of background behind it. When we introduced ProShare about a year ago, we wanted to make sure that we could get it in at the right price point so that people could afford it. We decided that price point, after some research, was about $2,500, and there was no way we could bring an H320 compliant product to the market at that sort of price point, as was borne out by the price of other products on the market that were H320 compliant. However, we did want to provide H320, and we've worked really hard over the last year to do the software technology required to provide H320 compatibility in an architecture such as ProShare, where we rely on the CPU in the computer to do some of the work. That's what helps us get the cost down.
Right.
So now we're shipping ProShare H320 compliant products rather. All the people who've bought ProShare in the past will get free H320 upgrades.
Right, so what other areas are you working on within the standards issues?
Well, actually, as part of the presentation that I have here, I have a couple of slides in here that are talking about some of the different technologies that we're working on. So, for example, if I now switch to the whiteboard that I have as part of ProShare, I have another couple of slides in here. If I switch to this one here, I can force Brian to it as well. This talks about our work that we're doing currently on H320, as I mentioned earlier. Primarily, it allows us to connect to other manufacturers' products, which is clearly important for those customers who've already made an investment in video conferencing. We're also working to provide multi-point support. Currently with H320, you get the capability to do multi-point through the services provided by different vendors. And I think, Brian, you know more about multi-point than I do, so do you want to go for that?
Yeah, sure. What we're trying to do is provide multi-point support to as many people as possible. And our software, as we're explaining here, is that it's now freely available to users to enable them to have an H320 multi-point conference, using the service provider in your particular geography. So, in the US that would be AT&T or Sprint, in the UK that would be British Telecom. And the graphic here that you brought up, Steve, is basically showing a desktop. Is basically showing a desktop user here talking to two room systems. Yeah. What you would see in the middle here would be a multi-point control unit, probably just in this area here, the intersection. So what we are saying now is that with the free software upgrade the existing users get, and the product that the new customers buy today, which has the software included, they're able to do multi-point just in the same way as traditional room systems have been able to do in the past.
And pricing is very important to us, Michael. I mean, I've mentioned that earlier. We didn't want to provide H320 unless we could provide it at an affordable price.
Right.
Our target was sub $2,500. The product is selling in the UK at the moment at £1,549.
Right.
Our challenge is to take that product down to about a $500 price point in the early 1997 timeframe. And we would like to think, as I think the last slide in this presentation shows, is that by the end of the decade, by the year 2000, we'd expect this sort of capability to ship with every PC out of the box without you needing to pay any additional price for it.
All right. And can you finally then fill in for me between now and the year 2000 some of the key points that we're going to achieve as far as you're concerned?
Okay, so some of the key points are clearly price points to make it affordable for users so they can put this into many, many locations and take advantage of the sort of capability it gives them for increased competitiveness and more productivity. But also some of the structural issues are very important. Multi-point we talked about, we touched on briefly, the capability of having people video conferencing together with more than two people on the line. An important extension to that is going to be the ability for multi-point with data and application sharing, so that you can do the sort of thing that Brian and myself were doing with that presentation, but with more than two people participating in that conference, as is fairly typical. So I would say that those are probably two of the most important vectors that are going to be going on over the next few years.
Steve, there's clearly some fascinating developments between now and the year 2000. Thanks very much for coming and talking to us about them and showing us ProShare. And thanks very much, Brian.
My pleasure, Michael. Good morning.
Hello. The 1st of June is the official announcement date for the dealer pricing for Microsoft Windows 95. Since Microsoft no longer publish RRPs, we have made our best estimates as to what the street prices will be. The price that everyone's been waiting for is the upgrade from Windows 3.1 or 3.11 to Windows 95. Lantec's best guess will be around the £69 mark for floppy disk or CD-ROM and £64 for the single license pack. And we're taking orders now. Here are all the details. Hit pause to read more. Good news from Hayes, who have just posted second quarter profits after their aggressive reorganisation following their sojourn into Chapter 11 territory last November. Dennis Hayes said, "Clearly we're on track for a solid recovery." To celebrate, they have just launched a V34 PCMCI modem card and have demonstrated their new DSVD technology. This stands for Digital Simultaneous Voice and Data, a digital technique to allow users to talk whilst exchanging data over a single dial-up telephone connection. At present, this is only a technology demonstration, but Hayes do have a habit of leading the communications industry. We'll bring you more news as and when it becomes available. Lotus have released Internotes, which, say Lotus, combines the power of Lotus Notes with the reach of the Internet. Internotes Web Publisher, the first product in the Internotes family, automates the process of publishing information approved for public consumption on the World Wide Web by converting Notes documents into HTML, the web document standard. Internotes News comes next, giving users managed access to the newsgroup discussions that affect your business or industry. As usual, call your Lantec account manager for details. Data Ease 5 for Windows has made its appearance. PC User did a review and stated, if you're a Data Ease user with an investment in legacy applications or an organisation not yet committed to a Windows-based database, it's worth taking a serious look at Data Ease 5 for Windows. Literature is available from Lantec, of course. IBM have just announced a new high-performance ThinkPad. The 340 DS3 is the newest addition to the 340 series and offers a 66 MHz 486 processor, a 360 MB hard disk, an IMH battery and a 10.4-inch dual-scan colour screen at an RRP of 1715. With echoes of the two previous news items, IBM and Lotus have jointly announced an easy-to-use electronic mail package called Lotus CC Mail for the IBM Global Network. This will be preloaded on IBM ThinkPad PCs. ThinkPad users will be able to send email messages virtually any time in over 700 cities and 100 countries around the world by using IBM's Mail Exchange services. IBM Mail Exchange takes care of routing messages through different networks and email systems and provides easy credit card billing, and there's a free trial period for users to explore the potential of this service. Lotus will provide CC Mail Mobile, which features simple online registration to the IBM Global Network. Looking further into the future, Fujitsu Laboratories have developed a new LSI device for fast processing of digital video images. Based on the MPEG-2 protocol, the new chip expands and decodes compressed digital images. It can be used for regenerating both NTSC and PAL television images. All the circuits necessary for signal expansion and decoding have been integrated on a single chip, so that by attaching a general-purpose dynamic RAM, it's possible to achieve decoding and regeneration of compressed digital image data at up to 20 megabits per second. The new chip looks set to be used in many sorts of computer and domestic data-to-video devices. It may well, for example, bring us cheaper, better video laser displays and real-time VCR quality video to our PC screens. Novell and the Business Networks division of Ericsson Telephone are planning 2 multimedia workgroup products based on ISO Ethernet technology. The companies have also agreed to bundle a range of their respective products to deliver a series of teleworking and computer-integrated telephony combinations. The Multimedia Station Kit will be designed as a complete client-based multimedia upgrade product, including an ISO Ethernet board, video camera, and encoder-decoder. All this comes together with personal conferencing software for the end-user client, say the companies. It will also enable the transport of speech data and video across the same cabling structure. The products will be available by the end of the year, but there are no prices yet. Now here's a few events for your diary. Hit the pause button to take down the details. And finally, a researcher at Cambridge University has demonstrated a speaker-independent voice recognition system working in something like real time. A researcher in the Department of Engineering, Tony Robinson, demonstrated his system that works by recognising phonemes, groups of vocal sounds. However, the demonstration showed that the technology still has a way to go. The words 1, 2, 3, 4, 5, 6 were translated as who 1, 2, 3, 4, 5 deaths. Mr. Robinson said that it works better for someone like a newsreader. Perhaps we should see what it could make of me. And that's Lantec's Industry Update for June 1995. Now here's Steve.
In the last edition of Video Interface, in the Industry Update section, we gave you a very first look at Intel's new processor, the P6. There was a lot of interest generated about that, as you might imagine, and that's why we are delighted to have with us today the technical manager for the P6 processor from Oregon in the USA, John Hyde. Welcome, John.
Thank you, Steve. It's nice to be back in Britain.
We're very pleased to see you here, and especially because you've actually brought a P6 with you, haven't you?
I've actually brought quite a few props to talk about today. What would you like to know about the P6, Steve?
Well, we showed a picture of it in our news section last time, and I think the most noticeable thing was that in fact there were two integrated circuits in the one package. So perhaps you'd start your explanations of what the P6 is going to do for S&P about with an explanation of why two chips.
Oh, certainly, Steve. If you'd like to hold the planet Earth's most significant engineering challenge.
I've been eager to do so ever since I saw it in your hands, yes. Okay, let me put this under our overhead camera here so we can get a good close-up view of that. That's a real P6. John, would you explain what we're seeing there, please?
Oh, certainly, Steve. What we have in this package are two die. The larger of the two, weighing in at 5.5 million transistors, is the P6 processor itself. We have a closely coupled cache, which is actually non-blocking in the same cavity, as you can see in the same package. This is actually 15.5 million transistors. So all told here we have 21 million transistors.
Right, a significant quantity, more than the Pentium even.
The Pentium processor was 3.1 million. So at 5.5 we're almost twice the number of transistors,
right.
Yes.
Let me pick up on a phrase you used there. You said non-blocking cache. That's a new one on me. What's the meaning of non-blocking?
Non-blocking is important for today's microprocessors. Over the past several years, the microprocessor has become faster and faster, and in fact it's significantly faster now than memory. So what the P6 processor does, it actually runs almost twice as fast as the P6 processor, but it's able to do this with much slower memory. Let me give you an example. Mm-hmm. The Pentium processor, for example, when it needs a variable that is not inside its cache, will issue an address on the bus. The Pentium processor will then wait for the memory access, we get the data, we come back and we give the data back to the Pentium processor. It then continues to operate. So this is blocking, okay? Mm-hmm. So the Pentium processor stops executing while getting the information from memory. So you can see that a big speed difference between the processor and memory will mean that this will cause the Pentium processor to run slower. Mm-hmm. What we do with the P6 is subtly different. While the P6 is executing and it wants some data, it puts an address on the bus, but then it continues to process. So it looks ahead in the program to find other work to do. And indeed, while it's working these instructions, it may discover it needs another variable. So it can put that address on the bus as well. And in fact, the P6 processor can do this 4 times before information comes back from memory. So that's what we mean by non-blocking. The P6 processor continues to execute even when data is not available. Mm-hmm. So it chooses other work to do.
Right. We alluded briefly to this by way of using some of the words out of the Intel news release that came out when the P6 technology was first announced. The P6 actually has a very different way of executing instructions from the Pentium, doesn't it, in general?
We did it because of this big speed differential between the processor and memory. What the processor does, remember the Pentium processor can look at 2 instructions at a time to decide to execute those. That's not a lot of visibility into the program. The P6 does it a very different way. The P6 knows where the current program counter is, and it predicts where the program flow is going to go. So what it effectively does is reads ahead 20 up to 30 instructions and presents these to the microprocessor core. The core then analyzes these instructions using data flow techniques. So it's trying to work out which instructions are dependent upon other instructions. The P6 processor then chooses the order of instructions to execute. So that's not the compiler. We're actually doing this at runtime, okay? Deciding which ones to execute because we know the latency of variables and things. So you will agree that if a variable takes a long time to access from memory or a short time to access from cache, you would actually schedule those instructions in a different manner. So the P6 actually schedules instructions according to data availability.
Right.
So this results in many of the instructions executing not in their normal natural sequence. So we have a lot of out of order execution inside the P6. So there is another processor inside the P6 called a retirement processor that actually looks at instructions as they're completing and finishes them in the same order that a Pentium processor would.
Right.
Because although it's quite safe for us to do out of order inside the processor, you wouldn't want to do out of order in the real world. I mean, just imagine, missile has been launched. Please enter authorization code.
Yes.
Right. So we don't want to
Nice
reorder
example.
the outside world. But internal to the microprocessor, that's how the P6 can get up to twice the performance from standard code of a Pentium processor, 100 megahertz.
Right. How, let me ask you, it occurs to me as we speak, how accurate is the P6 at predicting the correct course of action?
Actually, because the P6 is looking ahead 20 or 30 instructions, that will typically be 5 or 6 branches. That's a lot of correct prediction that the P6 must do. So we invested many transistors and very sophisticated algorithms in that part of the branch prediction of the P6. And over these 5 or 6 branches, he's typically better than 90%, which is very accurate. So that's how we're getting the performance.
Right. The inclusion of this memory within the package then was almost inevitable, wasn't it, when you have a system that is going to execute instructions this fast?
Yes, it was interesting. We asked manufacturing if we could do this, and they said no. Well, because it's never been done before. So we said, well, could you try it? So they tried it, and they said, oh, we can actually put 2 die in the same package for no additional cost. Indeed, the P6 is made with the same silicon technology as a Pentium processor, the 100 megahertz version, and the same packaging technology as the Pentium processor. So there's not a lot of additional cost in doing it this way. We get a lot of benefits, however, because look how close the memory is to the processor. This interface between the P6 CPU and its L2 cache is only ½ an inch long. So we can actually run this interface at the same speed as the core, which in this example is 133 megahertz. So if you've ever wondered what a 1 gigabyte per second bus looks like, that's what we have between
There's
these
one
two
between
parts.
the left and the right there.
So this is 1 gigabyte per second between these two parts. The bus to the outside world, which is where you'd connect your memory, is therefore low utilization, and we've included many other features on the bus to do that.
I realise now how little I know. Tell me, let's change the subject for a moment. I'd like to talk about Pentiums for a moment.
Okay.
I've noticed that Pentiums are getting smaller. Is this advances in manufacturing techniques coming through here?
Yes, I've actually brought a selection of Pentiums here. Let's show it to your audience here. Now, this is 2 years of Pentium development. The larger one, which is in fact the same size die
we can see here,
as the P6, is a 0.8 micron processor. This is 60 megahertz. So 0.8 micron is the line width of the transistors. That's the variable I'm quoting here.
Right.
So this was our first Pentium at 60 megahertz. We've also now got this center Pentium processor. This is the 100 megahertz Pentium processor running at 100 megahertz. 0.6 micron line width means the die is actually much smaller. And on the other end here, we've actually got a 0.35 micron processor, the 120 megahertz Pentium. So as we improve our processing technology, the die gets smaller, and since it's smaller, it can now actually run much faster. So this 2 years worth of development here has actually doubled the performance of the Pentium from 60 megahertz to 120.
Right.
We will, of course, be doing exactly the same to the P6 processor. It's starting on a 0.6 micron process, and we'll soon be moving it to 0.35, and then indeed, in about 2 years' time, we'll move it to 0.25 micron. So that, again, will be faster again, and cheaper and cooler. It's excellent. It's such a pity it cost us $2 billion to build a fabrication plant to make these. But we do it more often.
I'm sure Intel must have considered it money well invested,
Oh,
otherwise,
yes.
otherwise they wouldn't have done so. You also have a board here which I'd like to show briefly, where clearly it would seem to me anyway that we're expecting multi-processors of the P6
yes.
variety on there.
Right.
Can you explain what this other board here is?
Oh, certainly. Because of the two die of the P6 where most of the CPU traffic stays inside the package, the external bus to where one connects memory and I/O is a low utilization bus. We don't use that very often. So it was actually a small step to include all the features on the P6 external bus that would support multiprocessing. So all of the cache coherency signals, all the snoop logic, all the arbitration is actually included. So it's now simple to just basically step and repeat to make a multiprocessor system. In the past, a large part of the complexity of a multiprocessing system was getting the cache coherency right, getting all the snooping right, making sure the right person had the right data. That's actually all included in the P6.
Right.
So the OEM doesn't have to design that. So the OEM, the person who makes the computers, can then focus on building a very comprehensive board like this. In fact, with 4 P6s on, this board would actually run 1500 TPS, which in the US would cost you over $250,000. But a P6 version, an OEM could actually make this for less than for less than $100,000. So this is less than half the price of today's server.
John, we've clearly got an incredibly powerful range of processors here that are going to get even more so as the track widths get smaller and so forth. What are we going to use all this power for?
That's an interesting question. I mean, the Pentium processor obviously has enough power to run the operating system. The P6 with more power will actually be used to reduce some of the hardware complexity of a PC, which will reduce the cost. For example, video conferencing currently costs over $1,200 for the add-in board. With the additional performance of a P6, it could do much of the video processing in software. So the add-in board for a P6 video conferencing could be less than $100.
Right.
So much of the hardware additions like 3D rendering, sound recognition, things like that can now be done in software. So we'll now see additional capabilities added to the PC using this additional processor performance.
Right. And when do we start to see those capabilities?
We've been working with many of our OEMs since the beginning of this year. They are readying systems to introduce in Q4 when we introduce the P6 processor.
One final question. The Pentium is called the P5. What's the P6 going to be called?
The P6 is currently the P6. I've talked to the person who's going to choose the name and in fact the price, and Andy Grove hasn't decided yet, I'm afraid. We'll find out in Q4.
You'll let us know as soon as you do, no doubt.
Certainly.
John, thanks very much for joining us today.
Thank you for inviting me.
The latest issue of Byte magazine features IBM's PC Server 720 under the thought-provoking headline, Your Next Mainframe. We've decided to feature this super server and have invited along IBM's PC Server Marketing Manager, Mike Hope. Welcome, Mike.
Hello, Michael.
Mike, before we actually look at the Server 720, perhaps you could explain the rationale behind bringing a super server to market.
Yes, we've been studying the market for quite some time, and typically today, if you look at the servers that are in use in the marketplace, then probably 70% are being used as file or print servers, the traditional network environment. But there is 20% where customers are beginning to downsize applications and databases from other platforms and are really looking for a machine with more power, and in particular more processing power to satisfy those application needs.
Right, so what are the key features then of the 720?
One of the key features is its multi-processing capability. As I said earlier, application and database serving requires a lot of processing power. This machine is able to take up to 6 100 megahertz Pentium processors, and you can actually mix speeds. So if Intel come out with faster processors in the future, then you can put those in as well. It also offers enormous potential in terms of disk capacity, up to 40 gigabytes of disk internal to the machine, 7 high throughput PCI slots, and also the quite high level of memory, up to 1 gigabyte of error checking and correcting memory. So the potential there is enormous to be able to scale the system.
Right. It's something of a beast. I'd like to look inside, and maybe you can talk about some of the features of which you're particularly proud. So allow me to use the magic of television to open up the system.
Well, now that we've got the cover off, can I point out to you that immediately we can see that there's expansion capability in here for up to 18 hot plug drives, and these are 2 1 gigabyte drives in there. And you might be asking yourself, well, why is the need for that amount of expansion apart from data being on the system? Well, in designing the machine, one of our key attributes we were looking for was scalability, i.e. the ability to grow from 1 processor to 6 processors in a linear fashion. And we found that to keep 1 Pentium processor fed took at least the throughput of 5 drives of information. So to get true scalability, we felt it was important to have the ability to expand drives to be able to keep all those Pentium processors fed.
Right, okay. And the boards and so on that you've designed in the system?
Yes, the Pentium processors sit on interprocessor bus, which runs at 400 megabytes per second, which is very quick, probably one of the fastest in the industry, and again that aids scalability, and those are installed in the back of the machine.
Okay, how have you dealt with the issue of high availability, Mike?
Again, that's a very important aspect for these type of systems. It's not just the ability to go fast, but also the ability to be available. As I said, all the drives are hot plug, and they're supported under RAID arrays, so RAID 5 is supported on the system. The memory within the machine is full error checking and correcting, which is obviously important if you're going to be putting up to 1 gigabyte of memory inside the machine. And also throughout the system, we've ensured that we've put in parity checking on all of the buses. That's the processor bus, PCI bus, and also on the disk subsystem as well.
Right, and isn't cache important for when you're talking about that kind of throughput?
Absolutely, caching of the processors, again, to keep them fed with information. We have a level 2 cache which sits with each processor, which can turn information to the processor very quickly, and we've also built in a level 3 cache, again, to keep those processors fed to give us scalability.
Right, so clearly a very complex server system. I imagine that installing and, more importantly, continuing to manage the system is going to be an issue.
Yes, and we've thought about that. It's one of our big themes for this year and into the future, is making PC servers a lot easier to manage and a lot easier to install in the first place. You might notice that the machine comes with a CD-ROM drive. It also comes with a collection of CDs, which we call Server Guide, which sort of step you through the installation process, make sure the machine's fully optimized for the environments that you're working with. And also Server Guide has a package on there called Netfinity, which gives you server and client monitoring capabilities. And I think that's something that you looked at in the previous video interface.
Mm-hmm. Right. So IBM has perceived a market, has developed a system and designed the system for that market with scalability, manageability, and all those features that are vital for super servers. You're saying, I guess, that people ought to be talking with IBM about their super server needs.
Absolutely. If you come back to the article where it's, the controversial headline, "Your Next Mainframe," this is very much where these machines are now going. And if customers are looking to put mission critical and business critical databases on these systems, then they need to look at the aspects of scalability, reliability, and also the availability and manageability of the system. And IBM is very well placed not only to develop the technology to support these environments, but also to be able to support with our resellers these types of complex environments.
Right. Mike, thanks very much for showing us the PC Server 720.
Thank you.
Our special guest for June has a wonderful job title. He is Visiting Professor of Human-Computer Interaction at London's Imperial College of Science, Technology and Medicine. He was also one of the founders of the Media Lab at Massachusetts Institute of Technology. He has been chairperson or an invited speaker at many international conferences on subjects such as video conferencing, multimedia and communications. He is Professor Patrick Purcell. Welcome, Patrick.
Thank you very much, Stephen. I'm very pleased to be here and to contribute to your series.
We have seen in the programme so far today some phenomenal new processing power which is going to hit the PC screens on our desks. We've also seen video conferencing in action and data sharing. Tell us about your view of the impact of the transition to a digital infrastructure.
Well, both here and previously at the Media Lab, been concerned with the impact of the digital infrastructure on a whole range of applications, and the phenomenon of convergence of various media sharing the same digital conduit, and the progressive growth of that convergence phenomenon, paralleled by its apparent opposite divergence, the possibility of having those media, digital media, being transmitted in a plural range of options in the field of networks, in telecommunications, applications like thin wire television, and also in terrestrial and satellite broadcasting.
Right. There are so many ways that information can come into the home. Is any one going to be dominant, do you feel?
No, I think one of the virtues of this technology is its plurality. And to use another phrase, ubiquitous media, the media that's there when and where we want it. I'm mindful of what I call the tyranny of traditional television, where you had to be in the location at the time of that broadcast, where the program originated, was transmitted and received in the same instance. Now, with the technology of open architecture television, we are able to consider making the program, transmitting it, receiving it and storing it in a decoupled environment.
Mm. So providing random access, you might say.
Random access,
television.
offline television, paralleled by dial-up movies, video on demand, and so forth. All of these are predicated on initiative being taken by the members of the audience when and where they want to view it.
Mm. This is going to change the whole face of publishing in all its forms, in paper and television and films and movies and everything, isn't it?
Well, it is. There's a whole paradigm shift. I mean, we're having to revisit our cliches and the familiar concepts of broadcasting and the media generally. And for example, in the familiar concept of broadcasting and its two correlates, multicasting and narrowcasting, and more recently broadcatching, we are looking at different aspects of this digital technology.
I think you'd better explain broadcatching for us. That's a new phrase to me.
Broadcatching is a technology which sees the listener or the viewer as exercising initiative to have that program of their choice, where and when they want it. It's a term to, it's the, if you like, the antidote to broadcasting. It's a different approach to that technology that we have become so familiar with, and it's going to be very different in the future.
Mm. It occurs to me that advertisers hate video recorders, don't they, on television, because you can fast forward through the adverts. How are they going to approach this new technology?
Well, their role in the context of publishing, which increasingly will have a electronic format, and the associated technology of Infoget, it's a radically different approach. Mm. The familiar idea of an advertiser, if you like, creating an advertisement and then doing a blunderbuss, sending it out to the audience, is one that's going to be challenged by the idea of a advertisement being created and that advertisement sitting in a network until that user wishes to access it, to dial into it. I want to change my tires, so I access that advertisement, which has to sit there passively until I want to use it.
Yes, you mentioned
Infoget. Yes,
I think you better explain that one as well. Sorry.
All these new terms.
New terms and expressions.
Well,
yes.
they have to. The new terminology had to be created to because the old familiar terms are so gradually losing their, if you like, their reality. And I'm talking about telephony, television, radio, electronic publishing. The impact of digital infrastructure is going to create new concepts, and Infoget is one of them, where the replacing the publishing, the dissemination of information, the information electronically is going to be stored, and the reader or the viewer is going to come to it at their own time and going to dial into it and going to use some of the new concepts to aid that navigation through complex information environments to access that information.
What sort of cultural changes is this going to make to us as human beings and people across the world?
Well, one of the, when you mention culture, one of the obvious ones is the role of multimedia information systems, where the information is, for example, about the Louvre or the National Gallery, and European and American galleries and museums are now taking a very strong initiative to place their collections in a digital framework to be accessed nationally, internationally, and indeed globally across those networks. Some voices express concern about this, that it will replace the experience of visiting a room full of Leonardos or other modern masters. I say that it will complement that experience, and that the people who go to see the originals will see them in a much more informed frame of mind.
Yes. So you feel it will enrich the experience rather than replace it?
I feel that it will certainly inform the experience rather than the sort of typical casual museum or gallery visitor that we see today.
Right. This process we used to say was technology-led. Is this transition still being technology-led?
Well, certainly technology push does exist, but it is to some extent being overtaken by application pull, or content driven. And this is reflected in the new structures that we see evolving in the industrial environment, the new media conglomerates, the new global communication companies that are being formed to be able to span that content with communication. Another example is Sony's association with Columbia Pictures.
Indeed.
And Ted Turner's association with Hollywood, MGM.
Yes, MGM, yes.
And that is an awareness of the importance, the growing importance of content in the sort of duality of content and infrastructural technology. And it is also reflected in the way in which we will have to conceive, script, direct, shoot, and transmit digital movies, for example. The insidious thing about analog and digital is that in the media they look superficially identical. A digital movie is indistinguishable from an analog movie. But more and more, as the significance and the opportunities will present themselves to the people who make movies, then you will see a very different medium, a very different movie and a very different television program. Multi-scenario movies and so forth. These are some of the possibilities that exist. We are living in a certain sense in a first generation, in a horseless carriage situation about digital media, just coming to the realization of its its potential.
Right. When Professor Spence visited us here at Christmas, he said he was really looking forward to the future of technology. Are you as enthusiastic about the future as he is?
Well, I'm certainly enthusiastic about the future. I wouldn't be actively involved in this area of digital media if I wasn't. But it's a interesting and promising prognosis. There are major issues like public access to information. There's a lot of political rhetoric about the information society. Nevertheless, when you look hard at the situation, you find that there is a growing divide between the technical elite and the rest of the populace, and the fact that the fiber that has been laid in the ground is being artificially constrained in use. I would say somewhere between 10 and 20% of its capacity. And that's something that has to be addressed.
That's interesting, because actually our guest on our last edition said that 80% of the fibre underground and under the seas was dark. So it's interesting to hear that from you as well.
And the difference between cost and tariff is also another aspect of that situation. But I think that growing competitive structures will probably tackle that situation.
Professor Purcell, thank you for joining us here and bringing us these insights.
My pleasure.
And that's it for this edition. That was Video Interface Edition 16. I think it's been a fascinating programme. I hope you think so too. We'll be back in August. In the meantime, if you wish to get in contact with us, give us a ring, drop us an internet email, of course, or send back the reply paid card. That's it. Bye-bye for now.